So far, what we've done is we've estimated distances, areas, and volumes with finite sums, meaning having limits or bounds, okay? That means you have limits or bounds. So when it says, I want you to find the area between the, what is it called again? The interval 1 and 5, 1 and 3. Do you see how it's finite? Do you see how it's got bounds? So now we're going to move beyond the finite sums, and as the terms become infinitely small, then their number gets infinitely large, okay? So let me say that one more time. So as the terms become infinitely small, their numbers get infinitely large. All right, so we'll show you that. And that's why we use summation notation. Have you guys ever heard of summation notation? You've never heard of that? Summation notation? Never done summation notation? All right, well, we're gonna bring it in now. And usually, did you guys do summations in Algebra 2 at all? With the sigma? Never seen it before?
Sigma, I've heard of sigma.
I know about it.
You've heard of it? Okay. I was just curious. I think we did it way back in the day, and I haven't, by me teaching Algebra 2, I don't ever remember teaching the summation notation. So, so I guess you did it from calculus. All right. So we use sigma notation to express large sums of numbers, guys, in compact form. So this sigma, this Greek symbol, that's sigma, okay? And it's just Greek for sum. We're just summing a ton of numbers, all right? K is denoted as an index, and it tells us where to begin. So, you know, it's not a big surprise that we're starting at 1, right? And what do we love in calculus? 1 or?
0.
0. Okay, good. 1 or 0. Then the n tells us the number to end the sum. So what happens when it just says n? It just says n. So are we going to ever end it?
No.
We don't ever know when we're going to end it. You know what I'm saying? Right? So that means it's going to go on forever. So if infinity is above the sigma, that means the term's going to go on indefinitely. It's just going to continue to go on. But the n represents that it is going to stop somewhere. Does that make sense, guys? So if it's infinity, it's just going to continue. But if there's an n, then it's just going to stop somewhere. All right? So we just have an arbitrary graph, and what we have, like I'll show you guys the video, and maybe he probably explains it a lot better than I do. But we're adding a ton of x values. So yesterday, what we were doing is we did it by hand, and we drew what, 5 rectangles? We can add 5 rectangles by